We are looking at this problem, first bad version. You are a product manager currently leading a team to develop a new product. Unfortunately, the latest version of the product fails to qualify check. Since each version is developed based on the previous version, all the versions after a bad version are also bad. So you have something like this. Let's say n is 5. So you have versions like 1, 2, 3, 4, and 5. Let's say 2 is a bad version, which means 2, 3, 4, and 5, all these versions are bad. To determine if a version is bad or not, there is this function is bad version. It takes a version as an input, so we can pass these numbers to the input, and it tells us if the version is bad or not, and it returns a bool. In this problem, we are supposed to find the first bad version, which is in this example 2. And we should not call this function too many times as we are given this constraint. You should minimize the number of calls to the API. Let's first take an example. Over here, it's given n is 5 and we are given a bad of 4. So 1, 2, 3, 4, 5. Bad is 4, which means 5 is also bad. So the output would be 4 over here. This bad of 4 would not be given to us. It's internal information and we can take it out from the isBad function. So a very simple and naive approach to solving this would be, how about we call isBad version for every number? So is bad for 1, is bad for 2, and so on until we find 4, which is the first bad version. That would be an O of an algorithm. Over here, we are supposed to do better than that. We are supposed to minimize the number of calls. Now, let's approach this problem with this thing in mind. How about I have these numbers? Instead of going one by one, how about we jump? How about we jump to some place and check randomly? The one thing we know for sure is that every number after the bad version is bad. So if we jump to, let's say, 3 is the bad version, we jump to 4, 4 would also be bad. So 4 may or may not be the first one. We know it's bad because we call this function with 4. It may be an answer, it may be not. Where do we have to check? The first one is not going to be in the right direction. The first one would definitely be in the left direction. So now we can say that we can ignore that last part. We can ignore any number after this. These cannot be the first. So we are only left with 1, 2, and 3. 4 may be an answer. But 1, 2, and 3, this is where we should be looking. Now, this is very close to the binary search, in which we had numbers which had an ascending or a descending relationship. Over here, we have very similar, where we know that after an element, every other number has a very similar relationship. In a binary search problem, we used to say that on one side we have smaller and the other side we have larger. In this problem, we can say on one side we have good and on other side we have bad. It's the same logic. So now let's take a look at the code implementation of this. I'm here in the code editor. Let's take a left hand side. So the left side would be at 0. The right side would be at n. Okay, I apologize. We are not supposed to start from 0. We are supposed to start from 1. So we have to make sure we are doing one indexing. The left is 1, right is n. Let's say while left is less than or equal to right, I want to calculate the middle. Middle would be left plus right, integer division by 2. Now over here, I can check if the middle is the bad version. That would help me decide further. If is bad version middle, if this returns me a true, this is a bad version, which means every number after it is also bad. Every version after it is also bad. If which means I have to choose the left side. I can move the right pointer to middle minus 1. Now, if this is not true, I can say that I have still not received a bad version and the bad version should be on the right side. So I move the left pointer in this case, middle plus 1. I can continue doing that until the left side is greater than the right side. Now, what do we return? When do we find out the first bad version? Over here, let's take an example because it is very hard to imagine. Let's say we had something like this. The left was here, the right was here. The middle comes out to be this. Let's say 2 was the bad guy. So I'm over here, which means I should move right. So right moves here. Let's calculate another middle. This would be the middle. Am I on the bad? Yes, I'm on the bad version. But I should continue looking, right? I should continue looking for a worse version. So again, the right moves to over here. I calculate the middle again. This would be the middle. In this case, is this a bad version? One is not a bad version, which means in this case, the left would move. So the left would actually move over here. So now the left and the right are on the same place. What happens in that case? The code still executes. We calculate the middle again. What would be the middle? Is the same index. It's the 2 that is middle again. Is it a bad version? Yes, it is a bad version. What do? We move the right to the left. So the right now moves over here. So right is at 1, left is at 2, which is our answer. And this loop now breaks. So what do we return? We can return the left side. And that's how, in the end, we would be returning the left index, not the right index. Okay, so we have a problem here. I think it's not really self dot is bad version. I think it's defined in some other class. Yeah, that was not right, is bad version. Let's submit it. So we have it passing.